Hello there, dear YouTubers. My name is King1993, except in this case, I will call myself as the Colorless King or Mr. Colorless King. So, hello there, dear YouTubers or the visitors of colorlessking.info website. The website is not ready yet, but this will be the name of my website and it will look kind of like this. And the topic of today's video is going to be about the fourth dimension of the CKDM model. Okay, now you might be wondering, okay, what is the fourth dimension going to be and how it is going to be different compared to the rest of the other model like we know about space-time. Okay, but before going to those part, let's see how many type of animation is here today. There are total 6 animation. This is one of them, and this is another one. This is another one where this thing will move. Don't worry, it is about the atomic clock. And this is a receiver jammer stuff, and this is a tower related topic of frequency and stuff, and this is finally going to be the last one where how every planet has this sequence of sending information to other planets. Okay, so let's start. So what do we know about the CKDM model? The rules of the CKDM model is the following, and what are those following? The followings are that every CKDM model must need to have this following thing, which is called a chart. What type of chart is this? First, we need to look for what? Observation. Then we need to repeat the experiment, and then we will do the logical conclusion, making a logical conclusion. Then we can do math, and then if the math is not equivalent to the observation, then we will do what? We will evaluate the entire process. Okay, the reason I am saying this is because the topic in my fourth dimension is are the following. What are the characteristics of the fourth dimension? So this is the definition of what the fourth dimension is. Okay, so first of all, what do we know about the Euclid model? In the Euclid Euclid model, we know it is a what geometrical dimension. Okay, this dimension can be used for space related topic like how much is space is available, or how much length, width, or height is needed for a certain object. So it is a tool of what? Measurement. MEASUREMENT, measurement. Okay, so these are the two main topic which will be about what? Euclid. But if we talk about the Euclid dimension, how many dimension are there? It starts from 0 and then 1, 2, and then 3. So what is 0? 0 is like a point. So let's say this is 1 point, and from there there is this line which is called 1D, and then you can stack multiple 1D to create what? A 2D surface like a triangle. And then you can also do a lot more, such as if I were to use a square, okay, which has what? 1 2 3 4 4 lines. 4 plus 4 8. Okay, 4 plus 4 8, and then another 4 will be added. 1 2 3 and 4. So this is the Euclid dimension. Now Euclid dimension, as I've already said, is a dimension of what? Space. Is a dimension of what? Is space plus measurement. Okay, so if we get the proper measurement correct, then we can be able to know how much space is needed for a box. Okay, but here's the thing. If this is the Euclid model, then what is the fourth dimension? Okay, what is the fourth dimension? The fourth dimension is a little bit tricky to understand. Okay, what do I mean by that? Allow me to explain. The fourth dimension according to Einstein, the fourth dimension according to Einstein and his teacher Minkowski is called space plus time bending. But I say this is a wrong hypothesis, because Lorentz transformation, okay, Lorentz transformation created a chart where he basically said that ether is what causing light to cause the space and time to bend, and how the higher the velocity, the higher the velocity, the more the speed of light will remain the same. Okay, so something like this. The higher the velocity, the less will affect it will be, something like of those categories. So the question is, how can we fix this? If we want to fix this, we can have another hypothesis, and this is my hypothesis, the CKDM hypothesis, that the sun is already spreading what information to where, to the earth, right? And as a result we can see what reflection, and because the reflection is reaching to our eyes, 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 okay, then what will happen? We can see the reflection. So in between the earth and the sun, there is not a single atomic molecule available in between them. Rather, if there are large molecule in between them, such as the moon, then we can see the shadow of the moon. Or if the moon is in this place, then from this place we can see the what reflection of the sunlight hitting the moon. So if this is the case, then this area here is already a zone of non-local, non-local, okay, this is the non-local zone of information transfer. So the question is, how is the sun sending the information to the earth non-locally? It doesn't need to travel between what atom. So the question is, okay, then what is atom then? Atom is the sender of the non-local information. Now if I say atom, 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 atom sends, SEND, sends information, okay, information, how? Non locally, okay, so this is locally. So atoms can send information non-locally, and when atoms are nearby each other, then what will happen is, I have already made a diagram for this, like how the nearest atom can get affected, which is somewhere around here. Okay, here it is. So this is the model that I have made before, where I said think that this is a torchlight, okay, and this torchlight is basically hitting the nearest atom, which is the atom B, and then atom B will hit the atom C, and atom C will hit the atom D, and it will go on until rest of the atom that are available in this way, okay. But here is the question: what would happen if there were no atom between A and D? Okay, like there was no atom B or C. How is this gonna happen? This is exactly where the following thing happen. What is the following thing happen? That when we look at the sun from the earth, we see nothing here, and yet the earth is receiving information from the sun, which is an indication of non-local information sending mechanism, okay. But the question is, what is my fourth dimension then? In order to understand the fourth dimension, this is where I have made this thing, which is called the mirror, okay. Now why is that? So here's the thing: 1D, Euclid 1D is like what? A line. We can see a line, right? We can see a wood on the side, and this is 1D. And if we can stack multiple wood together, and then what will happen is we can, or we will be able to see a wall of what? Wood, right? And then if we want to make a box, we can make a box, okay, using a frame, and then put joint in between all of them, and it will eventually look like that it is a 3D object. Now here is the thing: the concept of 4D, or let's say the CKDM 4D, not just any 4D, CKDM 4D, is how can we see the back of the what? The back of the box. This is the main question. If we are human being who are able to see information 2D wise, okay, if we can see information 2D wise, which I called it the frontal or surface level information, okay, we can only see this part of the box, but this part we can also see, but this is the behind part. We cannot see this or this part. So how can we actually do that? Okay, in order to see behind of the box, let me give you another example, like a Rubik's cube, right? Rubik's cube. So in a Rubik's cube has how many sides? A Rubik's cube has total 6 sides, but we can only see the front up side, the front right side, and the front left side, but we cannot see the back lower side, back left side, and the back right side. So how can we see this? In order to see this, we need what? A mirror. So let's say this is just a ball, right? And the ball has the same color on both sides. But how can we know it has the same color on both sides? By parallax effect. Parallax effect is like how human has two eyes, and using the two eyes we can see two different directions. Like we can see depth using this method, right? So if we can use the parallax effect on the mirror, then the question is, let's assume that we have a green ball. So if we have a green ball on the back side and the front side is a red ball, then how can we get the information from the behind? We can get the information from the behind using a ball or using a live camera. So a live camera or a mirror is the thing that I called the fourth dimension. Now it might seem boring, but hear my logic carefully. When you can see the behind of the ball, which is going to be one color, and the front of the ball, which is another color, the question is, why can we see the behind of the ball where I already said that we cannot see the behind of a 3D object like this Rubik's cube? In this case, we need something that can bend the light. Okay, and what can bend the light? A mirror. But a mirror is bending light. Okay, we can understand that, but what is mirror actually bending is the path of information. Now what did I say about the CKDM 1D? The CKDM 1D is like a line that will go and move forward forever. They will only refract when there is an atom. They will only refract then, or they will send the information back. So in this case, what is happening, that we are using the mirror, or we can use the mirror to see the backside of a 3D object. Okay, and this is one of the first intuition that I want to give, that many people are going to say, how is this 4D? This is 4D. And now you might be thinking, well, aren't we using a mirror on a regular basis? Then how is this even a good intuition? Now allow me to explain. We think a mirror is a natural part, but we should be asking the question, what would happen if the mirror or reflection didn't happen? What would happen if the reflection never occurred? Then what would happen is, in order to look at ourselves on the face, okay, we need to tell other people, how does my face look like? Okay, so let's say there is human A and human B. Human, and this is the mirror, but this is a mirror, but the mirror does not cause reflection. So this A person will always ask B, how do I look like? And this B person will always ask person A, how do I look like? But they will never be able to use the mirror, because the mirror is what? Is not reflecting the reality. If the reality didn't allow reflection, but because reality allows reflection, we have taken reflection as granted. But we need to understand that reflection is part of what? Atomic reality. So CKDM is what? CKDM is a matter of understanding the quantum effect of the atom, and the quantum effect of the atom does what? They does reflection. So this is why the CKDM model of reflection is a very important part of the positive fourth dimension. Okay, this is why I am saying that a mirror is a very good idea, because this mirror will be able to help us even understand that what is the behind of the Rubik's cube color is going to be. So if I can change the color to something else, okay, let's say somewhere between yellow. Okay, so now it is yellow. Okay, so now what we are able to get, we can get the information from behind the object using the mirror. So this is point number one. Now the another point of the CKDM model is, how do electron chooses the double slit experiment path? Now this is a very important topic. Okay, so we say that the electron is choosing path. Okay, and how is it choosing path? This is the detector, this is the slit, and this is the uh, electron emitter. So the question is, how does the electron know which path to take? That is because this is an important part, like do they actually go here or do they hit there? Obviously I already said that electron never actually goes through the slit. They will always resonate with this part, okay, this part here, because electron only affect what, the metal. Now after interacting with here, they will either go here or in different direction. Now the question is, how do the electron know if something is there or not? Because in order for something to know, we need to understand the electron is coming out from where, this device, right? Before this device even sends an electron to this place here, this device is automatically knows where something is or not, okay, like a sonar effect. And by doing that, they will always know what is there. It is like the electron knows where to go before even going there. This is an important part of the fourth positive fourth dimension of the CKDM model. Okay, this is what like a omnidirectional sonar effect. So what is my fourth direction called? My fourth, sorry, not direction, dimension. My fourth dimension in the CKDM is called omnidirectional. OMNI, omni directional, omnidirectional information, omnidirectional information, information sender, SENDER. Not only sender, sender and receiver, plus receiver, R for receiver. Okay, so it is more like an omnidirectional atomic resonance. So this is what it is called, the fourth D. Fourth D is omnidirectional atomic resonance. This is the shortest version I can come up with, but it is another okay, I forgot one. Omnidirectional surface level atomic resonance, ODS OTSLAR. Okay, this is the most benefited or most intuitive name I can come out with. Omnidirectional uh, surface level, all omnidirectional surface level atomic resonance. So how do this work? In order to understand this, we must first need to look at this thing here. Okay, a tuning fork. So how does a tuning fork work? So when you click on one of the tuning fork, okay, if they are from the same frequency, then what will happen is affecting one will cause the nearby atom to get affected. Now people will say that this is happening to air. True, it is happening because of air, but what if there was a glass in between? Okay, if it was completely inside a vacuum and it would still resonate, then we should be able to understand maybe it is a quantum effect. Okay, so imagine the tuning fork, there is two of them, and they are inside a vacuum of each other. They are completely separated. If vibrating on this can cause vibration here, then we could understand what happened, but that doesn't actually happen. It only happens when they are nearby each other. So the question is, okay, why are they even vibrating together? Okay, why does vibrating this one causes vibration here? The reason behind that is, this is what we called uh, frequency resonance. So frequency resonance is already a topic. So if I say, okay, why is, let's say this is an LED light. Okay, so this LED light is putting what, a ray of light or maybe light information on a book. Okay, on a book, and now the book is shining by reflecting the information back. So the question is, what is happening there? The light or the atom or the LED light, which is made out of what, atom. When the atom in this place here, vibrate at a certain frequency, the book here also try to vibrate in the same certain frequency, but the vibration frequency of the book is much lower than the vibration frequency of what? The source of the light. As a result, the light will bounce back, but it is going to get a lot less hotter than this place here where the light source is emitting the light. Because here's the thing, in the tuning fork, what you need to understand, that the source of the tuning is going to be a lot more hotter than the source of the absorption. The reason behind that is, in order to actually make something even vibrate, you must need to heat it with what? You need to heat it with energy. So you need to put more energy here, but the moment this thing vibrate, the information is going in all the surrounding, and as a result, this will cause the nearest tuning fork to eventually what? Vibrate also. So from that point of perspective, we need to understand that the information that is happening from this area is getting spreaded not only in this place, but in the rest of the area also. And if you are living in an atomic environment like the earth, then the air molecules will eventually absorb some of the vibration also. So, and as a result, if we can click on this one and this one is not here, we can still hear the vibration information, which means that the tuning fork in the fork A is vibrating not only to this one, but it is also vibrating to our ears, which is why if we click on this one and if let's say this one is gone, we should still be able to hear the information in our ears, which means it is resonating not only with this one but the entire area. So what does this said about the double slit, which I already explained. Now vacuum action at a distance, I already explained, like how the sun is doing the information related topic to the earth, and there is no solid in between, and the earth is still receiving information from the sun, that type of thing. The bridge between connection, okay, this one is not needed. Engineering, okay, this is not needed. Let's see. Mirror omnidirectional surface level atomic resonance, okay. Tuning fork jam, okay, here's the one. Fork tuning fork jamming, I think it is this one. But before going to this one, if someone says what about the atomic clock, okay, isn't fourth dimension space and time, and if fourth dimension is space and time, if fourth dimension is space, fourth dimension is space and time according to Einstein and Minkowski, we should need to understand what does it mean. Okay, allow me to explain. According to Einstein and plus Minkowski, plus Minkowski, Minkowski is the teacher of Einstein, who was in the stage of development of physics era. Okay, so they were like classical people with classical idea of physics. So they thought, if the three dimension of the Euclid three dimension is what? A volume of space, VOLUME, volume of what? Space. Then after volume, the fourth dimension, the fourth dimension could be space and time. Okay, then came Lorentz transformation. Lorentz transformation tried to maintain the Maxwell equation of how all the observer of light is receiving the information at the same speed. The observer effect, why all the observer notices the speed of light at the same. That is because light was measured by a certain person named Albert A. Michelson or Michael A. Albertson, whatever his name was. He measured the speed of light in a mountain. This is the emitter, E for emitter, and this is the receiver, R for receiver. So what these guys saw, that the speed of light was being reflected back and forth up to a certain amount, and eventually he said about 300,000 300k kilometer per second. Okay, so when we talk about this thing, we need to understand that this area here is what made of, is full of atom. This area is full of what? Atom. What type of atom? Air molecule type of atom. So air molecule type of atom, which was this experiment was done at night, is always going to be condensed. Air molecule, whether it is any molecule, let's say atom, any atomic molecule obviously all molecules are made of atom. They are gonna what, they are gonna condense during the night. So it is a condensed effect of speed of light in a condensed matter effect of air molecule. As a result, we can get the number c, which is about 300,000 kilometer per second. So after it was done in that way, another way it was done was in a lab. In a lab there were multiple what, reflector, multiple reflector. So we need to understand the property of the reflector is what, they are made of atom. So what happens is, let's say this is the source of the light. Reflector goes there, then there, then there, and then there. In this way, the reflector measured the speed of light in a vacuum, and the vacuum was basically like a extremely good vacuum because there were no ray of light, only detectors. So eventually when they hit the detector, they saw that the speed of light is almost similar to what Michael A. Albertson detected in the mountain. And but here's the thing, every reflector are made of what, every reflector are made of atoms. So every time we are sending information with an atom, they are getting what, they are getting processed and then getting sent back to another atom here, and this way eventually to the detector. If it was measured in a direct way, then only then it will be possible. But I will explain a direct experimental method not in this place, rather in the 15th dimensional topic, which is I call the instantaneous atomic information resonance. Okay, so if we assume that space and time is not bending, okay, then we need to assume that maybe the speed of light is instantaneous. But in a classical physics of atom, the atom processing power or a processing limit causes the speed of light to become the constant c. So this is how I think it is. So for this we can do the following thing. So when we say the atomic clock is actually dilating, we can do a certain experiment on the atomic clock itself. Okay, so the thing about the atomic clock is made out of what, atom. Atomic clock is made out of what, atom. See, atomic clock is made out of atom. So if an atomic clock is made out of atom, then obviously according to the reality, which is electromagnetic, then the atomic clock will be affected by a what, a strong magnet. So this is the third idea. So what we will be doing is going to take a measurement of the atomic clock in a lab, spinning extremely fast in a certain orbital, okay, in a lab. Okay, and then we will measure what, we will measure the effect of the dilation. Let's say after doing it without the strong magnet, the time dilation of the atomic clock, let's say whatever it is about, let's say 1.1 x. Okay, because we know it is happening with a speed. Then what will happen if we use the strong magnet? Then if we use the strong magnet, then maybe the effect will become almost 2 or something, or maybe 1 point, maybe more than 1.1. This is a hypothetical measurement, like it could be, where it was 1.1, now it is going to be more than 1.1. So it is going to be more than 1.1. Okay, so this is what I am saying. If special relativity is saying that the velocity increases this, then I would say that the strong magnet could also do it, but even more. So why am I saying this? I am saying this is because there was a certain experiment which was done by another scientist who goes by the name the Zeeman effect. Zeeman, EFFECT effect. Okay, so in the Zeeman effect, what this guy did, this guy used a certain measurement device to look at the frequency of light using a certain crystal to see what type of color they show. But eventually this guy Zeeman saw that when the atomic clock was near a very strong magnet, the atomic clock would dilate. But not only that, the frequency within the atom itself causes multiple line or multiple spectral line affecting, which is called anomalous Zeeman effect. So anomalous Zeeman effect. It causes an anomalous Zeeman effect where the amount of spread actually increases a lot more than necessary. So normal pattern is about 1, 2, or 3, okay, but after 4, okay, it becomes anomalous Zeeman effect where the magnetic field actually gets so strong that it affects the what atomic clock measurement. And when the atomic clock measurement gets affected, we see a speed or maybe a time dilation, okay. So this is how the effect happens of the atomic clock. The atomic clock measures what a frequency of what of electron in what a certain type of atom. Which atom was it? It is there is two atoms, strontium plus another is cesium atom. In both cases, strontium and cesium atom is used to look at the oscillation rate of the atomic clock by looking at the oscillation rate of the electron inside the atom. But here's the thing, if the magnetic field increases, then what happens is the spectral line increases, and not only that, magnetic field increases can also affect the oscillation rate of the electron within the atomic clock itself. So we should be asking, how can we replicate the test? This is how this idea came. So after doing the test in this manner without the magnet, okay, and then if we can use a magnet, a very strong magnet, and do the same experiment again, okay, then we will be able to know what is happening. Okay, so we should be asking, how can we do this experiment? Simple. Take a mu metal. Okay, what is mu metal? It is the type of metal that is used in an atomic clock to block interference pattern of all type. So mu metal is the metal that is used. Okay, now this is a mu metal box. Inside the mu metal box, place an atomic clock. Okay, and then make the atomic clock move around this orbital path in almost in the same speed as the International Space Station, which is about 7.1 kilometer per second. Okay, if we can do this experiment and then see if we have a discrepancy of 1.1, this is an estimated measurement, I do not know the actual amount. Okay, so if we can get 1.1, and then after using the strong magnet, if we can get more than 1.1, then this would suggest that the atomic clock is actually affected by its vicinity. And what is the vicinity of the atomic clock? The earth. Okay, so the earth itself is going to act like what? A massive magnet. And whenever the, let's say, international space station is orbiting the earth like this, then obviously the magnetic field of the earth is going to cause an effect on the international space station, and not only the international space station but the atomic clock also. It is like saying, in my previous video, it is like the it is as easy as a chunk. Okay, like this is a chunk of atom, what the earth, the chunk of atom is affecting this large chunk of atom, is affecting this small chunk of atom. And this is how the oscillation dilation is happening, not time dilation, it is oscillation dilation. So the oscillation rate of the electron within the atomic clock changes, and that is how we get the effect of time dilation. It is not actually time dilation. This is what I am saying. This is why this experiment is very important. Even though it looks very simple, but this is a very important experiment to prove that the Einstein was wrong. Actual space and time is not bending. What is bending is the oscillation rate of the atomic clock that gets affected despite having a mu metal shielding. Because at the end of the day, mu metal, okay, mu metal is what are made out of what? Atom. So if a mu metal is made out of atom, and we are thinking that by doing this we will remove the electromagnetic interference completely, this is a false idea. This is called uh, physics gone wrong, because we have only used what? we have only used Euclid and Newton mathematics. Okay, by who? Einstein. Einstein used the Euclid and Newton math to present his special and general relativity using the concept of Maxwell equation of electromagnetism. Okay, so Einstein used the electromagnetism of Maxwell equation, which is a quantum effect, and then directly used it to use the calculus of Newton, who in general Newton, that is, used the normal Euclidean geometrical idea to use the calculus. So Euclidean idea is a general classical idea of geometry. Classical idea of geometry. Newton used the classical idea of geometry to make calculus, and then Einstein used what? Einstein used what? Einstein used the uh, classical geometrical model of calculus of Newton to explain the Maxwell equation. So as a result, at the end of the day, Einstein is using Maxwell equation but saying that it is a gravitational effect. So how can this work? This will never work. This is the reason why I am saying this experiment is very important. Okay. Now let's move on with the next topic. Okay. Omnidirectional. Okay. This is oscillation, refresh rate. Okay. Muon buffering. In order to understand muon buffering, I think I will explain this topic in the positive 12th dimension. It is we will be able to understand it properly there, so I'm not gonna explain it here. Okay, gravitational lensing, I will talk about it later, not in this topic, not this one either. Okay, so resonance hijacking. Okay, so here it is, resonance hijacking. Now we shall be able to learn about the topic of the uh, radio tower. Okay, so radio tower, when it comes to radio tower, we have the idea of propagation wave propagation to get that a wave, like this is the tower example, this is the tower. So when the tower, let's say this is the tower again, so when the tower cause vibration, it sends information to the surrounding, and it sends a wave information like this. Eventually it gets what? Slower. So is this true? Actually this is half true. This is half true, because here is the thing. I said in my what 1D CKDM 1D that electron will go straight until there is an atom. Then if the atom is gaseous or liquid type, or maybe let's say transparent type, then they will refract. Or if it is a what type is it, let's say metallic type, then it will absorb some of the information and some of them will bounce off. Okay, now if this is true, then if we say that is there an angular momentum to electron, the answer is uh, if you use the uh, Paul Dirac Paul Dirac spinor math, then I will say no, it is not true in the way he explained. It is a different topic, so allow me to explain it my way. Okay, so when we talk about radio, first of all, let's learn a little bit about this radio hijacking, or maybe I should explain this one first, then I will talk about radio hijacking. So this is an animation I made where this is a tower, and the tower will send an information outside. Okay, like this. So we are thinking, okay, so this is this is the wave, right? No, this is not actually the wave. Allow me to explain. So when I said about this one, how light is affecting the surrounding molecules to send the information, and the further it goes, the more information gets absorbed by the surrounding atoms, and eventually the field of the area here at the last end is going to be less hotter than the close proximity one. Okay, so when the information is being sent from a certain vibration classical device such as this radio tower, then what will happen is the information is going to be sent not in only one direction, rather in the whole topic, all the whole area. Okay, For example, it will first reach to information B, then C, then D. Now we might be thinking, oh, A is sending all of the information to all of this one. No, information is being sent from the tower to the nearest atom, which is the B, then the C atom, which is the second nearest, then the D third nearest, and then infinity. Okay, so if we look at it from that point of perspective, what is actually happening is, as the wave is coming out, the atoms here are getting affected. Okay, and as the atoms are getting affected, they are doing what? They are doing a pull. Okay, now you might be thinking, okay, why are they getting pulled and then going back again? Okay, so allow me to explain this part. We know the thermodynamic effect, right? Like in the thermodynamic effect, if we take a box and then we cool the box, okay, we cool the box, and then what will happen is the air molecule will be on the bottom. Okay, this is called low entropy. But if we remove this C, if we remove the C with H of high entropy or hotness or heatedness, then what will happen is, they this dot is not going to be here, they are going to be in very far away places. So what does it mean? It means atom at low energy state want to be together to each other, but at high atomic state, high energetic, in a low energetic state they will be near each other, but in a high energetic environment they will spread apart as much as possible. And here's the thing, the reason I am made this one like this is because to give an intuition of what is happening. So as the vibration is spreading, the nearest atom are getting affected and getting slightly pulled towards the tower. But due to the thermodynamic effect of the nature itself, once the effect goes away, the atom then goes back to their original position where they were before the wave even came out. It is similar to the electromagnetism effect of the Maxwell equation. But here is the topic. Here is the topic. In this case, if it looks like wave, then how is it? Uh, how is the line is getting dimmer as it goes out? As I already said, because at the end of the day, when we say that atom is sending an electron information straight, then it meets an atom. Electron meets an atom. What will happen? It will absorb and go refracted, or it will reflect back. But if we talk about another topic, that is the atom now heated or not? The answer is that if the atom is get heated by, like, get attacked or contact with the electron, then obviously it will be slightly heated, right? Then if it is slightly heated, then a certain amount of energy is going to be still available inside this atom. So as the information is getting spread outward, hello, as the information is spreading outward, what is happening? That the information from atom B to Z, whatever amount it is, they are slowly losing energy. So let's say this is 100 zone point. This is 100 zone point. Okay, this is 99%. Okay, this is 99%. Then by this point, this is 98%. Then this is 97%, 96%, 95, and as it goes out and out, it will eventually lose all of its percentage. Okay, and this is the exact reason why any radio tower has a limit, but the more power is given to this radio tower, the longer the distance it will be. So this is how it works. Now if we think of the fourth dimension, as I have already stated, omnidirectional, where is it? Fourth dimension, fourth 4D plus 4D of the CKDM is omnidirectional surface level atomic information. Then it means that not information, atomic resonance, then DSLR, DSLR, OTSLR. Then it means that OTSLR, how is the OTSLR happening? The OTSLR is sending the information in not only in this area here, but in all of this area to the surrounding. Okay, like a total ball type of way. So it is sending information not only in one places, in all of the places. As a result, this sonar effect is the most intuitive effect I can give you. Okay, now let's move with this one. Okay, so the question is, how does a radio work? Okay, so here is the question. If we talk about radio, how does the interference pattern work with the radio? So you will get something like this is a radio tower, and this is a jammer, and this is a radio receiver. Okay, so people assume, let's say this is not here, that when information is being sent in all direction, it sends like a wave. It sends like a wave, and eventually it will hit this radio receiver. But if I say, then how does the receiver know what is information is being sent? Okay, how is it being sent? As I already said about the earth and the sun issue, that they are sending, the sun is sending information to earth non-locally. So the radio signal is sending the information to the radio receiver non-locally. So it is telling, okay, this radio tower is telling, the radio tower is made of what? Atom. So the atom at the radio tower is telling the radio receiver how to vibrate. Okay, and because of this reason of the vibration, the radio receiver is going to receive the exact information. But what happens if the jammer gets active? People think that when jammer gets active, it will send two different information, and eventually the main signal gets blocked here in the air, and as a result the information, it doesn't get to this point. Okay, this is completely false. This is the false idea. Okay, what is the true idea? The true idea is the radio tower constantly send information. Okay, but a jammer causes another. Okay, let's say this is the primary information. Okay, primary information. Let's say that the tower, radio tower, is the primary information, and the jammer is what? The secondary information. Okay, so when this is sending the information to this place and telling how the radio receiver should vibrate, only then we can hear it. Then what will happen when the jammer is active is the jammer is sending secondary information, or it is basically telling the atom. The jammer is made out of what? Atom. The jammer atom is telling the radio receiver atom how to vibrate, and because of this exact reason, the radio receiver vibration is going to happen. What is going to cause what? It is going to cause the nearest atom to behave how it should vibrate because of this. Otherwise what will happen is, block if we block only one channel, okay, let's say channel 1 is blocked, then the radio receiver will still work with channel 2. So how can we then stop all of the radio receiver channel? Okay, simple. We send a secondary information in all of its channel, and as a result what will happen is, when all of the channel of the receiver is receiving secondary information, which is basically random noise, then obviously all of the information that actually is coming from the primary information source, which is the radio tower, is going to get what? Blocked. As a result, the radio receiver is only going to resonate with the atom of the jammer, and this is what I call a resonance hijacking. So to give a proper demonstration, let's look at this tower here. So this is a radio tower sending a red information. Okay, now this is the radio receiver. Now we assume that when this one is active, these two are going to fight in the mid-air, and because of the fighting in the mid-air, this doesn't receive the information. This is the false part. Because why is this false part? This is the false part because of what Einstein said, that Einstein is saying that space is causing all the bending of the path. As a result, gravity happens. This is what Einstein is saying. This is Einsteinian point of view, and I am saying from the CKDM point of view is that the space has nothing to do with anything. Everything has to do with atom. Atom is causing what? Atomic resonance, and atomic resonance has what? A gravitational effect. So atom is causing atomic resonance, and the atomic resonance causes what? A gravitational effect. This is what the true reality is. Space has nothing to do with it. So which is why The reason I am saying that the when I activate the jammer, the radio receiver only receive the information here is because the resonance uh, material, which is the resonance atomic material, which is the radio receiver atomic materials. You can get the point, right? The atom inside the radio is receiving the information from the nearest power source. And what is the nearest power source? The jammer, which is why the jammer will not block the information from the radio. No, the jammer will block the not block, actually hijack. Okay, hijack, because the original effect is not gone, but it is causing a secondary effect, and the secondary effect is now causing the radio jammer to resonate with the nearest receiver, which is why when we say that the jammer is blocking the wave of the radio tower, it is half truth. Another half truth is it is not actually blocking anything, it is causing the receiver atom to resonate with the nearest powerful object, and that is the jammer. And that is how the fourth dimensional work. Okay, that is how the fourth dimension of CKDM work. The CKDM, the CKDM fourth dimension is odd slar, SLAR, odd slar, Omni, directional, surface level atomic resonance is causing the what? Is causing the atom of the sender to force the atom of the receiver to vibrate in the frequency that it is constantly telling this one how to vibrate. Okay, this is the thing. Now the last topic is, okay, then how can we say that the same logic will apply to the sun as well? Okay, before going to the sun part, I think I made a Curie motor here. So this is a colorless king Curie motor. Okay, what is this colorless king Curie motor? Allow me to explain. A Curie temperature is a temperature where the magnetic field of a metal loses its magnetic strength, and eventually it will not get affected by the magnet. So if we take a magnet such as iron and then hold it in place with a metal holder and then apply cold to the bottom and heat to the top, then what will happen is that the magnet will always stay active, but this metal will start to rotate. Okay, this metal will rotate. Why is the metal rotating? Because the heated part is not attracted to the magnet, but the cold part is attracted to the magnet. As a result, this will either move left or right, and the top part will go to the bottom slowly, and the lower part, which is cold, is slowly going to move up to the top of the magnet. Okay, so this is how the Curie temperature motor work. This same Curie temperature motor also apply to the sun. If people say, many scientists say the following thing, that the earth do not fall into the sun because this earth is constantly missing the trajectory of the sun. As a result, it is not falling into the sun. I say that is nonsense. Okay, that is nonsense. What I assume is happening is the Curie temperature effect. Okay, the Curie temperature effect is happening. So imagine that this is the sun and this is the earth. Okay, earth. Okay, so the earth, people are saying that it is constantly missing, and as a result it is not falling into the sun. It is not falling into the sun. This is not true. Then what is the true path, true reason? The true reason is when the amount of heat being applied to the front of the sun, or the earth that is facing the sun, once it gets heated, it either wants to be moved to the uh, clockwise or counterclockwise. Okay, and at the same time, the part of the earth that is away from the sun, like this part, which is the cold part, this wants to face towards the sun. As a result, the earth will either move clockwise or counterclockwise, like it is a constant pull and push happening. This constant pull and push happening is similar to what? Electromagnetism, right? Electromagnetism, like a pull and push happening both at the same time, similar to this topic as well. But in order to understand the push and pull even more better, we must need to understand the uh, uh, positive 12 and 13 dimension properly. There I will explain it there properly, positive 12 and 13, of what electromagnetism truly is, what is gravity, what is temperature, what is cold, everything will explain by those two. Okay, so in this case what I did, I created a sonar model. Okay, so when I click on this, it will send a sonar. Okay, and then as I increase the speed and then I turn on the continuous, then it will send a continuous signal to the earth. Okay, now if I were to lower the speed even more, this is the far better version. Okay, so if I increase the speed like this, okay, not like that, if I increase the speed like this, then people will think, oh, this is, isn't this the same effect as uh, uh, red shifting and the blue shifting? No, this is why I'm going to slow down the speed a little. Okay, the earth is constantly and instantly sending information not only to the sun, rather to all the object, to its surrounding. Okay, like a what, like a omni directional surface level atomic in atomic resonance. So it is the Ortslar, or basically let's say sonar effect. So the sun, okay, the earth is sending a sonar effect to its surrounding to know where what object is. Okay, but here's the thing, it is not only the earth, every planet, every atom, every galaxy, star, uh, moons, every celestial object always create what? They always create a resonance effect. We cannot see the resonance effect unless there are atoms nearby. Okay, and as a result, what will happen is, before the sun gets, sorry, before the earth gets too close to the sun, the way too much hot information, or let's say vibrational information, gets affected. Okay, like the sun is sending too much heat to the earth, and this is the exact reason why the earth do not want to fall into the sun. Because what do we know about electron? The thing about the electron, tron, the thing about the electron is, electron hate each other. Electron hate. Okay, electron hate each other. Okay, because of this reason, when I hit a metal rod, let's say this is a metal rod, if I put flame in this area here, then if the amount of flame becomes too much high, then eventually the heat will spread from up to the bottom, even though uh, normally the heat usually used to stay on the top part, but eventually, because it is receiving a lot of electron in this area here, the electron will eventually come down to the lower part of the what, lower part of this uh, iron bar. Okay, and eventually iron bar all metal, so eventually as it comes down, it will get more what is spreaded, the information will spread, information of what, vibrational information of the atom, which are basically the electron, will then send in the information to the surrounding area, which is contains what, air. Okay, and the more vibrational information the earth receive from the sun, the more it wants to stay away. So what is the sonar effect? The sonar effect is, the atom constantly knows where they are, whether we want them to or not. And because of this reason, the international space station, the international space station which holds the atomic clock, always gets what, affected. Okay, and because of this atomic clock getting affected by the atom of the earth, okay, then obviously the faster the atomic clock moves around the earth, the more uh, what will happen is interference will happen, and eventually the atomic clock will cause maximum amount of time dilation, because the oscillation rate of the electron inside the atom is constantly getting affected by the neighboring atom, and the main largest neighboring atom is what? The earth. Okay, and this is how this topic goes. Now I know that today's topic sound a little bit technical, but at the end of the day, this mirror was my main point. Okay, like I was doing a gym work with a certain person, and eventually I realized, wait, if we use proper way of thinking of how the electron, no, sorry, not the electron, of how we can see we can see the front side of a 3D object, but we cannot see the back side of a 3D object, but we can see the back side of a 3D object using mirror. But the question is, what is the mirror doing? The mirror is reflecting the atom. Let's say this is the mirror, and this is the back side of the box, and it is reflecting the information back to our eyes, human eyes. Then it means that in order to see the back side of a 3D object, we must need to bend the back side of the 3D object using what? The atom. And the mirror is made out of atom, and this is where I get the idea. Yes, the fourth dimension is actually omnidirectional surface level atomic resonance that allows the resonance to happen not in only one place, in every direction, which is why this earth idea is very good, but this could have been a lot more better. But this is using CPU to generate the process. The more I increase it, the more horrible it will look. And not only that, the uh, page refreshes, it gets affected. So I have only stick with 50 at a time, and it can activate a maximum of 10, and we can already see how it is affecting. But it is not going to be this obvious. The actual information sending resonance of the earth to the sun is happening more faster than we can imagine or visualize using our equipment, because at the end of the day, the equipment that we are using are made out of what? Atom. And if atom affects another atom, okay, if one atom affects another atom, then obviously this will basically cause us to understand more proper of how the atomic reality of the CKDM model actually work. Okay, so when I say, okay, when I say the following things such as why we need to have a proper intuition model of our reality, and that is the atomic reality, we need first what? Observation. Then we need to repeat the experiment, and we need to make a logical conclusion. But the logical conclusion of the Einsteinian special and general relativity went exactly wrong in the Lorentz transformation, because Lorentz transformation itself was incorrect, because assuming space and time need to bend in order to make the speed of light same for all observer. This is where the atomic problem started. Space and time do not need to bend. Okay, and this is the first topic. And the second topic is Einstein. This is let's say EU for Euclid, Euclidean geometry math plus what was it? Newtonian calculus plus the actual mechanism of Maxwell equation was used. And Maxwell equation is a what? Is a quantum property, is a sub-quantum property. And Einstein took these three idea and made a trajectory, made a uh, atomic path trajectory, without understanding that the exact reason is happening because of this quantum property of the Maxwell equation. Because Maxwell equation says a magnetic field causes an electric field, and an electric field causes a magnetic field, vice versa. And all of these are what? Happening inside the atom. So why are we not looking at the atom and looking at space and time? Because of Lorentz transformation. Okay, so this is the whole topic, and I was able to do this within 1 hour and 4 minutes. But the information that I have provided you guys using not just okay, let's see, not just this one, rather one, the mirror reflection effect by which we are able to see the behind of the object. The tuning fork analogy of where the tuning fork, the fork that starts vibrating the first will have more energy than the receiver atom. Okay, and then the idea of is experimenting. This is my actual experiment of the putting the atomic clock within a move metal shield and make it move around a magnet. Without the magnet and with magnet, we should be able to see the effect. Make sure to put an extremely powerful amount of uh, magnet, extremely powerful magnet, then the effect will be more apparent. Okay, and then the idea of how light this wave is propagating. Another important thing I forgot to mention here, I need to mention it now, otherwise it will become problematic later. So if a certain tower vibrate, okay, if we ask the question, uh, how, okay, not how, what is the frequency of POWER, powerful radio, TOWER, tower. So what is the frequency rate? The frequency rate depends, but it is starting with 530 kilohertz. So 1000 hertz is about 1 kilohertz. So it goes from 530 kilohertz to 1700 kilohertz. So you can probably guess that what will happen in this case. In this case, if I increase the speed, the hertz rate, you will see that there is a bug, okay, where the some of the air molecules are not moving like as they are moving in this slow area. Okay, this is a bug, but let me explain why this bug is important. It means every time this radio tower is vibrating, the atom that are basically not moving, okay, they are vibrating, but they are vibrating in their zone. Okay, they are vibrating in their zone. As a result, what you are going to see is, if you put a device in this place here, it will automatically vibrate and receive energy from the tower, because this is exactly how the concept of electromagnetism work, of how the tower is sending the information to the receiver. It is constantly causing an information change happening within very short amount of time, which is about uh, 530 kilohertz to 1700 kilohertz. It can go even higher, I think, I do not know. But when these things happen, what will happen is the atom will stay where they are, but they are going to vibrate within their space. Okay, so this is the last topic. So 1 2 3 4 5, okay, you can already get this one, and 6, total 6 diagram I needed to use to explain this fourth dimension as best as possible, which is why I think this is the greatest thing that the CKDM will be able to provide to the humanity. Okay, so goodbye, stay safe, and see you again next time.